You may recall in last week's lessons we dealt with triangles, we dealt with angles, we dealt with finding unknown side lengths. All of those things are actually interrelated. All of those things were actually getting us ready to deal with today's lesson, which is getting into trigonometry.
DRG?
The first thing we need to do is make sure your calculator is set correctly. So we need to make sure it's in degree mode. And you'll know you're in degree mode if you do sine of 30 and get 0.5 as an answer. And so now that we've looked at each person's calculator, made sure that everybody's is set in the right mode, we can now go ahead and just practice this idea, making sure that we can calculate each of these values. So really quickly, please calculate each of these values and round your answer to 4 decimal places, please. And so for that first one, you do sine of 60 degrees. When you do sine of 60 in your calculator, it gives you this big long decimal. Depending on your calculator, it's giving you some piece of this number. And this number just goes on forever. It's irrational. It goes on forever like this without repeating. But that's not, of course, our final answer. We need to round this to 4 decimal places. So if I'm going to round this to 4 then that means I'm cutting it off here. And I do need to take a look at the one next digit, which in this case is the 2. And I see, okay, does it round up? No, it's going to stay the same. So our answer is going to be 0.8660. One question that often comes up with this sort of thing, though, is do I have to write the 0 at the end, or can I just write 0.866?
Wait, why'd you do 4 numbers instead of just 2?
Oh my gosh, what the heck is this?
By writing in that 0, we show that we actually rounded to the 4th decimal place. Next up, let's go to cosine of 45. And yes, that's what that cos represents. The cos button is right next to the sin button, if we're looking at it that way on your calculators. So, do cosine of 45, which gives you, of course, a big long decimal again, and we look to see what we round it to. And we're still rounding to the same 4 decimal places, so that means I'm cutting it off there. And I look at the one next digit, the 0. The 0 tells me to leave it the same. And so my answer here is 0.7071. Right, last up, tan of 85. Tan of 85, when we do that in the calculator, you should get 11.4300, and it keeps on going and going and going. And again, we're rounding to the 4 decimal places, so that means I'm cutting it off here, and I look to see the next digit, only the next digit. Does it round it up or does it leave it the same? In this case, because it's a 5, I round it up. And so instead of 00 at the end, it's going to be 01. And so then that's our answer. A little side note, I don't expect you to memorize this, but it's awfully good information. Anytime you do sine or cosine, it's going to give you a number that's between 0 and 1, or -1, depending on where we're at the time. Tangent's the exception. They can go into all sorts of other places. Now, here we've seen sin, cos, and tan. Sine, cosine, and tangent. We also have these operations, which you would have seen before. These are called the inverse operations. Typically on your calculator, you can get to these by pressing second and then the sine, cosine, or tangent button. So for instance, to do inverse sine, I'd do second sine of 0.4. And so as we take a look at this first one and make sure you're on the right track, first of all, yes, we read that first of all as inverse sine of 0.4. That's how we're actually reading it when we talk about it. Now, when you do that calculation to make sure you're on the right track, you should be ending up with a big old number that looks like part of this. And of course, we are going to round this. Notice in these problems, how many decimals are we rounding to on this one?
2.
2 this time. And so then that means I'm cutting off after the 7. Notice that the one next digit's an 8. So that tells me to go ahead and round that up.
I don't know how to get that.
So you should get 23.58 when you're done. For the second one, we're doing inverse cosine, so that's second cosine of 0.75. And again, we round it. So there we get 41.41. And for the last one, inverse tan you should get 41.6690 and so on and so forth, rounded to 2 decimal places, and we get 41.67. Now, I started you just with the introductions where we're using the buttons on the calculator without any context for what they mean. But now we really do have to go back and think about what does sin, cos, and tan actually mean when we're doing all this. And this is where I'm bringing you back to geometry. Because back in geometry, you would have learned this. And notice, it depends on opposite, adjacent, and hypotenuse. Those same things that we were practicing last week. How do we call those names of the triangle so that we can handle sine, cosine, and tangent here? Now, if you do not already know the information that you see up there, add it to your notes right now. So, as you take a look at these are definitions you're going to need to know going forward. You need to know that sine equals the opposite over the hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, you need to know those. You need to memorize that. So, as some of you may recall, there actually is a particular word that we remember in order to remember sine, cosine, and tangent. We have SOHCAHTOA. Now, this is one way that you can remember the definitions of sine, cosine, and tangent. Now, it's not the only way, but it is a good way to remember sine, cosine, and tangent. And so, how does this help us? And again, add this into your notes if it's going to be helpful for you. The reason why this can help us to remember that is because S is sine. And remember what you just wrote down in your notes? Sine equals opposite over hypotenuse. SOH. Sine, opposite, hypotenuse. And that lets you remember that sine equals opposite over hypotenuse. Of these 9 letters, each 3 tell us one of those. So C, well, you can guess what C tells us. That's our cosine. And remember what cosine equaled? Cosine was adjacent over hypotenuse, which then gives us cosine equals adjacent over hypotenuse. And the T, of course, T would stand for tangent. And tangent, remember that was opposite over adjacent. And so we can use SOHCAHTOA as a single way to remember 3 different things. And so it's a nice short tool for remembering a few different things along the way. So now that we've seen what sine, cosine, and tangent really are, where they come from, we're going to be saving a lot of this kind of stuff for tomorrow, where we actually have to use those to write the equations ourselves, but because we need to see how to solve these equations. So that's going to be the next thing we do. Here I've given you a cosine equation. And we're going to see how we would actually solve that equation for x. So if I'm going to be solving this, of course that means I want to get to the point where I have x equals. Well, right now I have cosine of x equals. That means I have to somehow get rid of this cosine. Well, cosine is a function. It's not like I'm multiplying x by cosine. That doesn't make sense. Cosine is not a value. It's a function, like square root or something like that. So we have to have something that does the opposite of it. Well, we actually do. When we want to know how to undo a function, technically what we're doing is we are doing inverse functions. And so in this case, if I want to get rid of the cosine, that means I have to take the inverse cosine of both sides of the equation. We saw inverse cosine earlier today. Remember, inverse cosine is that cosine to the power of -1 function. And so if I take the inverse cosine of both sides of the equation, this is what my next step, algebraically speaking, looks like. So make sure you have this written down in your paper also as the next step. Once we've done that, Now we can actually do the inverse cosine of 0.25, because notice this looks like the types of problems that we were doing earlier at the start of this lesson. So once you get to that point, since it's x equals, now it tells you plug it into your calculator. And so we do that. We do the inverse cosine of 0.25. And in this case, I'm rounding to the hundredths, so that tells me 2 decimal places. So my final answer is going to be 75.52. Now I get to get detail-y on you. Notice that this answer is 75.52 degrees. When we do an inverse cosine, it's telling us an angle, because whenever we do sine, cosine, and tangent, whatever we plug in there has to be an angle measure. And so anytime, in fact every time, I do inverse cosine, inverse sine, or inverse tangent, I'm going to get an angle as an answer. Now that's not a huge concept to be memorizing and focusing on. I want you instead focused on the algebra that was involved here. However, it's going to become a bigger and bigger issue as we go forward, so I'm letting you know now so that it'll come back repeatedly. Right, now in this case, notice I'm starting you off with inverse cosine of x. Well, again, in the last problem, remember we talked about at the end how inverse cosine always gives us an angle? Well, notice it gives us an angle here as well. But how am I actually going to solve for x? Because I want to get the x by itself, which means somehow getting rid of inverse cosine. Well, inverse cosine, remember, is what we use to get rid of cosine. They are inverses of each other. And so if I want to get rid of inverse cosine, I can use cosine.
Oh.
So I'm going to take the cosine of both sides of the equation. Algebraically speaking, then, this is what I see on my next line. Because the inverse cosine cancels out, the cosine and the inverse cosine cancel out each other. Just leave me with x on the left.
So essentially, if it's a minus 1, you just do.
Alright, and now at this point, we have x equals cosine of 20 degrees. That's a value that, again, we can just calculate. So you plug that into your calculator. You should find that x is about 0.94 when rounded to the hundredth like that.